Hello, everyone. My name is Marcello Ardizzone. I work as a staff blockchain engineer at Polygon Labs for 3 years now. And today I will be presenting you the outcome of a very complex and long project we have been working on in the last 1.5 years, which enables Heimdall v2 by leveraging CometBFT. And in this case, we'll be looking at how we leverage that for cross-chain communication in Polygon. So as you may know, the architecture of Polygon chain is a dual-layer architecture where we have Ethereum as our security and settlement layer that we use for finality. Then we have our sidechain, which can run on Bohr or Aragon. In particular, Bohr is a fork of Geth, and it's basically the execution layer. And then we have in the middle Heimdall, which is a Cosmos SDK-based chain, based on Tendermint consensus, which acts as the consensus and coordination layer. And you can think of it as basically the nervous system of the network because it's coordinating all the cross-chain communication between layer 1 and layer 2. So there are many transactions that go back and forth from L1 to L2 and vice versa. We will be focusing on state sinks and checkpoints. Checkpoint is basically the way we commit the cryptographic state of L2 to L1, and state sync, the way around, is when you want to take the state from L1 to L2. For example, as a user, you want to deposit some funds on a bridge contract, and this needs to trigger some actions on L2. All of this is basically done by side transaction, which are non-user transactions performing the cross-chain coordination logic. And with the upgrade that we lately rolled out on Amoy testnet last week, we are basically upgrading Cosmos to the latest version 0.50 by removing basically a tech debt of more than 4 years development upstream. And we are migrating from Tendermint to CometBFT. So since this is not a backward compatible kind of upgrade, it's a coordinated upgrade where we will be wiping the blocks history, and we only keep the application data, and we are doing a regenesis to make it compatible with V2. We are also lowering the finality time by quite some high percentage, from 90 seconds to around 4 or 5 seconds. We are reducing the block time in Heimdall, and we are basically trying to solve the difficulties of current V1 side transaction implementation, where they're basically kind of outside the blocks execution workflow because of the limitations that Tendermint had back then, and we have to handle them by using some custom hooks, which make it difficult to reason about and verify. So with side transaction in V2, we are going back to first principles by using first-class consensus logic for side transaction and part of the blocks execution workflow. So here you have basically an overview on what are the main methods that CometBFT can invoke on the application layer, going from prepared proposal, where the transactions are included in a set of candidate transactions. You can order them basically and act as a decentralized sequencer, for example. Then those transactions are simulated and validated or rejected. And then there's this key step, which is the extend vote, right? Where you can basically attach non-deterministic data to the pre-commit messages. And here we basically embed our side transaction, which is nothing else than a stream of bytes, right? Then we can decode to execute whatever we want to do cross-chain. And then we have verify vote extension for the verification of the side transaction themselves. And at the end, in finalized block, this gets delivered to the app layer to basically commit the state. This is the implementation on one use case that we have, checkpoints, where basically at block X, the candidate set of transaction gets proposed by the round proposer, and the first one by design is always going to be a side transaction. And in case we have to submit a checkpoint, then it's going to be a message checkpoint. And in the same block, all the validators will process that proposal by simulating it at check transaction, and then we extend the vote by embedding the side transaction basically with the vote extension, which includes the signature of each and every validator, which then gets verified in verify vote extension, where everyone ensures that the vote extensions are well formed and signed. And at the end, at the next block height, at finalized block step, the results are retrieved from the previous block, and the vote extension which reached the supermajority of the voting power will be executed, so that in this case, the payload signed will be ready to be submitted to Ethereum. Yeah, I think we can get to a small demo. It's not purely a demo, but we will be looking at some logs. And if we are lucky, we will see a checkpoint going through live if the SSH connection is still alive. Apparently it is. So what I will be doing now is to trigger a state sync transaction on this GCP DevNet, where we have 3 validators running and 1 sentry. So what this doing currently is just generating a deposit on L1, which will be then fetched by Heimdall, and it will be verified by each and every validator, extended with votes, and in the end, basically submitted to BOR to mint tokens, or basically reflect the state of L1. So as we can see here, a checkpoint just went through, and we are waiting for the state sync. But basically, at step prepare proposal, which happens at this height, the side message server, which is our handler, was success, in checking that the state of the local BOR matches what is coming from L2. This validator specifically voted yes, and the same happened on the other one. And then all the checks on the message server were successful, so that at the next step, another checkpoint just went through. But basically at the next step, next block height, the checkpoint was submitted, and the post handler will be updating the state and flashing the buffer, waiting for a checkpoint acknowledgement, which is basically paving the way for the next checkpoint proposer to propose his checkpoint. And this is basically the result on Heimdall, where you can see that you have a new checkpoint being submitted, and you can even leverage this block to have a verification on the data by using this command that we have implemented, the vote extension decode. As I said, it's just a byte stream, right? And by the way, yeah, the state sync is what we just triggered. So it got detected by Heimdall, everyone voted yes, so it was successfully submitted. And with the decoding, we see basically that the vote extension was submitted at this height, at this round, and we have a set of votes, which includes the validator address, the power, and its result, basically yes voting. And you can see the summary at the end, where you see the side transaction with this hash voted by 100% of the voting power. And this is basically whatever gets submitted to L1, which matches what we just seen for the checkpoints. And if we want to see also at the state sync level, this is what just got submitted, 1 minute ago, which is whatever we just triggered on that DevNet, right? So I think that is basically it for the demo. So just wanted to present you that the way we migrated to V2 will basically bring native support for ABCI++ and vote extensions, and side transaction now for us are truly native and part of the dynamic blocks execution workflow provided by Comet. We migrated Amoy testnet successfully last week, and mainnet is coming up soon in the next 2 weeks. And this is just paving the way. It's just the first building block for what's coming next on Polygon chain with validator elected block producer, faster finality that we achieved and reduced block time. And next is going to be the integration with the AG layer. That is it for the presentation. Thank you. Happy to take any question. I think we're good. Thank you.